Hi, welcome back to our Windows Server 2016 course. What is new? So far, these are the modules we have covered, and starting from intro, platform vision, management, security, identity and access, storage, networking and compute. And under the compute, we have covered 3 or 4 sections. And for today will be around remote desktop services. Under the remote desktop services, we have 7 areas to cover, and it's including remote effects, GPU, the district device assignment, DDA, RDP graphic compression, codec, RD connection broker skill enhancement, cloud optimization, Azure AD, and multi-point service role plus personal session as well. So, quick overview. We have a connection broker redesigned and rebuilt to be capable to work with a huge amount of end user connections. In RDS 2016, can handle thousands of end users simultaneously or simultaneous connection without any issues, comparing to 100 in RDS 2012. Remote effects now support Windows Server 2016 on guest VM. Previously, it worked only with Windows Client OS. All problems with Windows Client not available for VDI can now be fully solved by using Server 2016 on a guest VM. And license through Windows Server Data Center license through SPLA that allow run unlimited number of Windows Server VMs on a host. Windows Server 2016 has Windows 10 like desktop experience that should suit the need of end users basically requirement. And now service providers can add remote effects capability to the solution. Remote effects now support OpenGL and OpenCL as an addition to direct access or DirectX. It now supports up to 1 GB of video RAM and per VM 4K resolution. Let's walk through these improvements one by one and see what happened. First, remote effects vGPU provide a rich desktop remote experience with Server 2016 and RDS, enabling multiple VMs to share the same physical GPU for graphic acceleration. OpenGL 4.4 and OpenCL 1.1 API support up to 1 gig dedicated RAM or VRAM and up to 1 gig shared memory available in a VM, up to 4K resolution support, and Windows Server 2016 VM support. Improved performance. Uh, what else? Let's have a look at the next part. What we got? Direct or District Device Assignment (DDA) support allow, similar to the Hyper-V, the previous session, allow some PCI Express device to be passed through directly to the guest VM. RDS can now take the advantages of DDA, enabling enhanced graphic performance, full graphic API support, for example, DirectX, OpenGL, OpenCL, CUDA, depend on the drivers basically. Native GPU driver support, Intel, AMD, NVIDIA, maximum performance 1 gig or 1 or more GPU to 1 VM, multi-user or RDSH support, multiple sessions can utilize the graphic card assigned to the basically VMs. Other graphic enhancement, codec investment, now implement full screen AVC, 444 mode, high quality 444 mode using standard H.264 AVC 420 hardware decoder, which reduced bandwidth and better experience at higher resolution. Also hardware offload support. Let's give you some info around this area. RGB graphic compression codec now implementing full screen AVC mode, reduce bandwidth and better experience at higher resolution, and same thing around hardware offloading. The graphic compression for RDP and AVC H.264 codec, the standard has been used by the RDP for a couple of releases in the ITU T H.264 codec, also known as MPEG-4 or AVC Advanced Video Coding. The benefit of this coder is that it's widely available in hardware so that CPU-intensive coder encoding and decoding can be offloaded to a separate hardware block. With RDP10, we are now taking the AVC H.264 to support step further introduction of the full screen 444 mode. So what is the AVC 444 mode? The main challenge to use AVC H.264 as the one and only codec in remote desktop scenario is that the text shows a halo effect with typical implementation of AVC H.264. This is caused by the color conversion process that happens as a part of the compression, which threw away some of the chromatic information as represented in the H20 format. To the human eye, the lack of the chromatic information is not apparent with video content. However, with RDS, where mostly text is used, it is something that is noticeable and users will perceive this as a blurry. The AVC H.264 standard defines the capability of the 444. So, with the Windows Remote Desktop Client mstsc.exe, the AVC 444 mode automatically uses the AVC H.264 hardware decoder available via the Windows DirectX Video Accelerator API. In addition, GPU must be DirectX 11 capable and H.264 hardware decoder must support level 4 and TB709 full range code. The RDP server can take advantage of any AVC H.264 hardware decoder to expose Windows via Media Foundation transform, and it is therefore not hardware vendor dependent. Next is the RD connection broker scale enhancement, enhanced to handle highly concurrent logon or sessions scenarios. The connection broker was tested with 10K concurrent connection with zero failure rate. RD connection broker requires SQL database. Previous OS version, a SQL cluster was recommended with 2 VMs. SQL database still required, however, SQL authentication is now supported. Shared SQL DP connection making even smaller scale deployment more cost effective. With RD connection broker, it enhanced to handle so many concurrent sessions that should address the need for a lot enterprise customers, whereas it used to be 1,000 per server on the previous release. Other cloud optimization, Azure Active Directory and SQL. RDS can utilize Azure Service to provide more cost-effective solution. Azure AD Application Proxy enables secure remote access to application. RD gateway servers are still required. Now they can be published in the application proxy service instead of exposing the public internet. This reduces the attack surface and enhance security. Conditional access can be created and um, um, trusted further to define how the user must be authenticated. Uh, what else we have? Basically, Azure SQL database includes high availability, disaster recovery, and upgrade mechanism. RDS environment using Azure SQL database eliminate the need to deploy and manage VM for SQL. And then, what Azure AD domain service provide? Manage domain service, domain join group, LDP, CareBus, RDS service environment using domain service to eliminate the need for managed domain controller. So, a lot improvement around the other improvement. Let's we have a look. What we got next is the multi-point service role. This is a new server role. It enable low cost, basically PRC desktop and compute, allow multiple users each with their own independent Windows experience to simultaneously share one computer. The unique tool set of this role allow you monitor of all sessions on the multi-servers. Multi-point does not user require remote desktop a connection broker, enabling multi-point service role. Also install remote desktop session host role will allow users to connect remotely. This is a new server role that easy to deploy and easy to manage. It enables low-cost desktop basically. Next is the being able to use personal desktop, support generation 2 machines, and using pen with RDS. We mentioned earlier being able to use Azure. So this is a comparison between on-premise and the cloud. On-premise, we can use session-based compute, virtualize or virtual desktop infrastructure. Session-based desktop and remote app, cost-effective, easy to manage. Access to pool and personal virtual desktop running Windows OS, high-performance app capability. Whereas in the cloud, we have RDS as an infrastructure as a service or IIS, and Ego Azure Remote App. Remote desktop session host deployed on a cloud infrastructure surface, customizable with minimum capex. Windows Server session based applications delivered from Azure Cloud, and again scalable without capex. A quick recap: evolving the end user experience around desktop virtualization. Generation 2 desktop virtualized or virtual machines, support for secure boot functionality from UEFI and faster boot time from reduced legacy device dependency. 1 GB RAM, larger video memory with OpenGL 4.4, OpenCL 1.1 API support to optimize the user experience for graphically demanding apps. So 1 GB virtual RAM. Pen input optimization for RDS as smooth as the local experience with support for pressure sensitivity, pen orientation detection, and pen button passes. And the last part is around personal session desktop, deploying individual server-based desktop so every user gets an assigned remote desktop session host VM. So that's all what I had for you for today. Hopefully you have learned something useful. Let's do a quick recap before we end the session. We spoke about all these nice and new improvements, and the high level again being able to assign direct resource from the PCI Express likes for example to the VM, and this is similar to the basically Hyper-V, which is GTA, and you can see the benefit. Other improvement around the codec for AVC with H.265 as well, and all around optimizing the bandwidth and being able to provide higher resolution like 4K and support the major codec. And we spoke about the connection brokers, and Microsoft managed to improve it to 10,000 concurrent sessions per server. Also we spoke about the benefit of using Azure, improvement around Azure, utilizing conditional access, securing Azure. Again, similar to what we have spoken about, all the new improvement around Windows, Hyper-V, they all fall into RDS as well. And then we've spoken about the new multi-point surface role, which does not require broker, and that should be able to support, you know, user sessions, support other, I would say, platforms. And then we spoke about being able to utilize pen and Generation 2 machines on RDS, which means with Generation 2, all the security improvement we spoke about, control flow guard, code integrity, device guard, and so on, they can be applied. And then we spoke about the two comparison between RDS and either, let's we describe it as a Zen desktop or Zen app equivalent, but with the Microsoft, are available either on-premise or the cloud. And we spoke about, the virtualized desktop as well improvement, similar to the session host improvement. That's all what I had for you today. A lot improvement, and I will say quick few words before I end the session. Whatever we have covered so far, from the compute, and we spoke about Generation 2, we spoke about all these benefits, then we move toward clustering, we move toward, storage space direct, and then Hyper-V, and then now we're landing toward RDS. They all apply to RDS. For example, when we mentioned supporting Generation 2 on what they call RDS, which means all the benefit around Generation 2 can be supported. Secure boot up, code integrity, control flow guard, device registration, device guard, it's a very shielded machine, and so on. Yeah. So bear in mind, whatever we have spoken about, they all apply here. Plus, being able now to support 4K and more direct assignment of resource toward the RTS, similar to what we have spoken about around Hyper-V as well. Thank you very much for watching part 17, and I shall see you at the next part. Goodbye.